Okay, it's recording. So yeah, we have talked about terminal voltage. Okay, let me explain again what is actually terminal voltage. Yeah, so we have this thing called terminal voltage. Okay, terminal voltage, and we also have what we call EMF. Okay, so it's like that. Yeah, imagine you have a battery. Okay, imagine you have a battery. Okay, a battery. So it has the, it supply EMF. Okay, supply EMF, but inside it has internal resistance. Yes, internal resistance. So okay, so you have this thing, yeah, battery with internal resistance. Okay, so this battery power up the circuit, yeah, power up the external resistance. Oh, sorry, power the external resistance. So let's say maybe this external resistor is a lamp, yeah, or a light, yeah. So this battery power up the light. Okay, all right. So we have this thing we call terminal voltage. Okay, what's the symbol? First of all, what is the symbol? Terminal voltage is VT. Yeah, VT. EMF is this. Okay, so terminal voltage. Yeah, terminal voltage. So let's say my EMF now is okay, my wait a second. Okay, so let's say my my EMF right now is 1.5 volt. Okay, 1.5 volt. Okay, however, yeah, my EMF over here is 1.5 volt. However, if I put a voltmeter, maybe around here, across here, a voltmeter. I measure the voltage of the, this battery is a 1.5 volt battery. Yeah, 1.5 volt battery. However, when I put a voltmeter across the terminals, yeah, because this one has, sorry, okay, hold on a second. All right, so sorry. So right now this one is we have a positive terminal, negative lah. Okay, so this voltmeter actually is measuring. Okay, it's recording, right? It's actually measuring the terminal voltage. It's measuring the terminal voltage. Yeah, that means voltage across the terminals of the battery. Understand? Although the battery is 1.5 volt, however, the terminal voltage I get over here is only 1.4 volt. The terminal voltage I got is only 1.4 volt instead of the battery 1.5 volt. Why this thing happen, class? Why the terminal voltage register less voltage compared to the EMF? Can you tell me why, class?
Because of the internal resistance.
Yes, because of internal resistance. Yeah. Please adjust your volume louder because I cannot hear your voice. Yeah, maybe your mic is very soft. Okay, please adjust it. Like this is okay. I can listen clearly. That's right, because got potential drop across internal resistance. Because this one, this one got voltage drop across internal resistance. We put this as V small r lah. V small r. Okay, so why? Because there is a voltage drop across internal resistance. So it's like, how to get this terminal voltage? How to get that terminal voltage? Terminal voltage is actually EMF minus IR. Understand, class? Or we can say terminal voltage actually is EMF minus voltage across internal resistance. This one is I multiply internal resistance. Okay, and yeah, and then VR is voltage across internal resistance. Okay, let me write it down. Okay, VR is voltage across internal resistance. So VR actually is current multiplied by internal resistance. Understand? Okay? Can you get it?
Yes, sir.
Good. So we can say that this is let's say 1.4 volt EMF. Put it as 1.4. EMF is 1.5. So how much do you think is the voltage across internal resistance? How much do you think? 0.1, isn't it? So we can say this voltage across internal resistance is 0.1 volt. Okay, 0.1 volt has lost through the internal resistance. So how to get the terminal voltage? Very simple. Just the EMF minus out the voltage across internal resistance. Because we can say this voltage across internal resistance is like voltage loss. Voltage loss lost through the internal resistance. So it only supply the external. It only supply the external circuit with 1.4 volt. Look at here. So that means what? How much voltage the battery get? Kalau we also put a voltmeter over here. So this voltage is voltage across external resistance. So how many voltage do you think the resistance get? 1.4 lah. Understand not, class? Because the battery only supply 1.4 volt to the external resistor. So external resistor only get 1.4 volt. It won't get 1.5 volt because 0.1 volt already lost through the internal resistance. So 0.1 volt already lost through the internal resistance. So the external resistance only get 1.4 volt. So it's like, parallel. So understand, class? So across this one, the terminal this one is the terminal voltage lah. Across the terminals, this is the terminal voltage. It is equal to EMF. What is all this? EMF minus the voltage loss across internal resistance. Which is 1.5 volt minus 0.1 volt. That's why you get 1.4 volt. So the external resistor get 1.4 volt lah, class. So in other words, we can say that terminal voltage is voltage across external resistor. If you can see that, terminal voltage is actually voltage across external resistor. That means this is what I'm trying to tell you yesterday, but not successful because I'm tired. I'm tired. My mind cannot think carefully. But today is okay. Yeah, better. Yeah. Okay. So terminal voltage. This is terminal voltage. VT is terminal voltage. That means voltage battery supply. Battery supplies for external resistor. After the EMF minus out the voltage loss through the internal resistance, so left with 1.4 volt. 1.4 volt is supplied for the external resistor. Understand, class? If you look carefully, okay, this formula, let me write it down. This formula actually is what? Look carefully, terminal voltage equal to EMF minus VR, isn't it? So terminal voltage actually is V across external resistor. Understand, class?
Sir.
Some of your voice I cannot hear. Too soft. Maybe your mic is very soft. Yeah, so I cannot hear your sound. And so never mind. So terminal voltage is voltage battery supply for the external resistor. So terminal voltage is voltage across external resistor. So okay, if I change, okay, we know that VR is IR lah. Understand, class? V small r is I small r lah. Understand, class? So we substitute this I multiply R EMF minus, and then VR is I multiply small r. So rearrange the formula is the formula that you're familiar. This one go to the other side, plus I small r. So this is the formula that you learned before in SPM. Correct, class?
Yes.
Yes, sir.
So that's the thing lah. That's the thing I'm trying to tell yesterday. Okay. You just have to remember that the terminal voltage is voltage across external resistor. And then V small r is voltage loss across internal resistance of battery. Yeah, of battery. Battery tried to supply 1.5 volt, but 0.1 volt has lost inside the battery itself. So the battery can only supply 1.4 volt for the external resistor. So the voltage across external resistor, the external resistor only receive the terminal voltage instead of the EMF. Understand, class? You only receive 1.4 volt. Okay, you see, there is two setup that I draw yesterday. If you can see, this is a complete circuit, kan, class? This is a complete circuit. So actually, we can find the current also, yeah. Let's say there is a switch over here. There is a switch over here. Okay, the switch is closed. So the switch is closed means got current flow, kan? Betul tak, class? Got current flow. So can you calculate the current? Let's say I know all this. Yeah, can you calculate the current? Yes, you can calculate the current, because you see, this is the one lah. Yeah, IR. I can calculate the current. You can calculate the current from here. You see that? So you can actually, let's say your voltage across external resistor is 1.4 volt just now, right? And your resistance is 10 ohm. So what's the current, class? What's the current? So voltage across external resistor divided by resistance, you get a current is 0.14 ampere. Correct, not, class?
Yes, sir.
You can get the current. You can get the current flow. Okay, class. But the thing is, okay. So you understand. At least you understand. Terminal voltage is EMF minus voltage across internal, minus the voltage drop across internal resistance. Okay. Now there is a two setup here. I want you to look carefully. So yesterday I did draw this. Okay, there's two situation. Okay, one is the switch is open. Okay, the switch is open. Another one, the switch is closed lah. Okay, this is the battery. Another one, the switch is closed. There is a two situation here. This one switch is open. This one switch is closed. Okay, this A, this is B. This is the switch lah. Yeah, this is a switch. So you have a battery. So you have a EMF, E, and this one got internal resistance. Yeah, got internal resistance. Okay, class. Now you put a you put a voltmeter there. Yeah, you put a voltmeter. Okay, voltmeter across here. This voltmeter surely measure terminal voltage lah, class. Understand? And then this here you have a voltmeter also. This voltmeter measure the external resistance. Okay. This one also I put the terminal voltage voltmeter here, and here also I put a voltmeter. Okay, class. If the switch is open, means got current or not? Can the current flow? Can the current flow? If the switch is open, got current flow in the circuit? Huh?
No.
Yeah, current is zero. Yeah, no current flow. No current flow in the circuit if switch is open. If switch closed, okay, one is switch open, one is switch closed. If switch closed, got current flow?
Yes.
Yes, got current flow. Yeah, got current flow through the circuit. Yeah, this is positive, negative. So current flow through the circuit. Got current. This one no current. This one got current lah. Okay, now class, I want to ask you. These two important situation. Alright. Okay. So I'm recording again. Yeah. So this one you see, if the switch is open, what I can say is, okay. First thing first. The EMF is 1.5 volt. I'm using a 1.5 volt battery. Yeah, EMF is 1.5 volt battery. Okay, but the thing is, if the switch is open, no current flow, this terminal voltage I will get 1.5 also. The battery is 1.5 volt. Okay, this terminal voltage I also get 1.5 volt. Yeah. And however, if I close the switch, got current flow. We know that the EMF here is 1.5 volt. Okay. So, but the terminal voltage I get here when the switch is closed, the terminal voltage straight away it will drop to 1.4 volt. Why, class? Why? Okay, because when so when the switch is open, okay, the current equal to 0, right? Okay, the current, okay, I should put this just at the top here lah. Yeah, EMF. You just put it over here. It's better. Yeah. EMF is 1.4. Okay. Battery. Yeah. When the switch is open, the terminal voltage I get 1.5 volt. Yeah, exactly equal to the EMF. You know why? Because when switch is open, the current is 0. The current is 0. That means no current flowing in the circuit. When no current flowing in the circuit, voltage across internal resistance, which is IR, when current is 0, so become voltage across external resistor is 0. There's no potential drop. There's no potential drop or voltage loss. No potential drop or we can say no voltage loss through internal resistance. Okay, when current 0. No potential drop. No voltage loss. No voltage loss across internal resistance. Yeah. So VR is 0 volt lah. Okay, that's why, because no current no current flow, that's why. So if you use the formula, VT equal to EMF minus IR kan? Betul tak? Tadi kan kita belajar ini kan? VT equal to E minus IR kan? Betul tak kelas?
Yeah.
So when current 0, so when current is 0, that means we will get the terminal voltage, we will get EMF because this one becomes 0. Understand? So that's why the terminal voltage here, you get EMF. You get EMF. Yeah. When no current. Yeah. When current. When current is 0. When current is 0, no current go through. That means this external this internal resistance is like tiada internal resistance is too. Yeah. It's like no effect on the circuit because no current. No current means no voltage loss. No voltage loss across internal resistance. So the terminal voltage you get EMF, which is what? Which is what value? 1.5 volt. Okay, and also voltage across this external resistor because also no current gun. Because also no current gun. So for the external resistor, which is IR, betul tak? Because the current also equal to 0, so VR also 0. This one also you get 0 volt. Understand not, class?
Yes, sir.
So that means when when no current flow, when switch is open, when no current flow, the terminal voltage straight away can get the value of EMF over here. You straight away can measure EMF. VT equal to EMF. This is the important one lah. VT equal to E. Okay, when switch is open, VT equal to E. Why so disturbing all this? VT equal to E. However, when switch is closed, what happened, class? When switch is closed, wait a second, I need to, need to adjust it a little bit lah, yeah. When switch is closed, what happened? Got current kan? Got current means this one got current. Yeah, this one I need to adjust a little bit more, this one got current. This one got current. Yeah. So got this one got got what? This one got VR, which is IR. It also got VR lah, which is IR lah. Understand? Okay. So what happened is if this thing got current. So this for this one it will be terminal voltage. Yeah, that means for this case, I want to say is this one got potential drop. This one got potential drop lah across internal resistance. Yeah, because got current. Yeah, this one got potential drop lah. This one got potential drop across internal resistance. So this one go below. So I can say that the terminal voltage, this one is equal to E minus IR. E minus IR. So got current, right? So that's why you only get, you know, your terminal voltage is like, you know, 1.5 minus 0.1. So you get only 1.4 volt. Understand? So that means for this case, your you know, your terminal voltage is less than EMF. Understand, class? Is less than EMF. Yeah, less than EMF. Last time if switch is open, the terminal voltage equal to EMF. But for this one, when switch is closed, the terminal voltage less than EMF. Because why? Got voltage already lost inside the battery. Okay. And then what else is this one got VR equal to IR lah. Yeah. And also we can say that the terminal voltage for this case, the terminal voltage actually is equal to VR. Understand? For this one, the terminal voltage equal to VR. Instead of equal to EMF, now the terminal voltage equal to VR. Understand? Like this one lah, which I explained just now. If switch is open, the terminal voltage equal to EMF. The terminal voltage is equal to EMF. However, when the switch is closed, the terminal voltage become less than EMF. Now the terminal voltage equal to VR. The terminal voltage equal to voltage across external resistor. Okay, class, do you understand?
Yes, sir.
Yeah, that's all for this subtopic. Yeah. Actually, it's all very simple. Just this formula E equal to IR plus IR, and then you rearrange the formula IR, the IR, I small r go to the other side. That's how you get the terminal voltage formula. Yeah, the terminal voltage formula. The I small r, you go to the other side. So it becomes this formula lah, terminal voltage equal to E minus IR. So just want to tell you that this terminal voltage here is actually what? Is voltage across external resistor. Understand? The terminal voltage actually is voltage across external resistor, which is also I big R. Okay? I big R. So it's actually just V big R equal to E minus V small r. That's all lah, yeah. So if V small r go to the other side, it become the formula that we recognize. Okay. Okay, terminal voltage is voltage across external resistor. Yeah. Okay, want to write it down for you. Terminal voltage is equal to voltage across external resistance. Okay, terminal voltage equal to voltage across external resistance. Okay, so that's all for this lesson. Okay, now continue with tutorial questions. Okay, so just off record for this one.